All right, welcome to this class, Operation with Surds. When you're talking about operation with surds, you look at it from the angle that they are irrational numbers. And one may ask, what are rational or irrational numbers? Any number, for instance, x over y, if they are not equal, if x and y are not equal to 0, okay, then x and y are therefore maybe integers, or decimal numbers or fractions, okay. So far they fall into these categories. They are what? They are rational numbers. But when you talk about irrational numbers, they are the things you cannot easily determine their value. Okay, something like pi or √2, √3, √5, etc. Okay, so these are irrational numbers. Now, if you want to operate a surd, the best you need to know is to find out what and what does it obey. Now we have four rules for surd. Rules of surd. We have multiplication. We have multiplication. We have division. We have addition. We have subtraction. So let's get it so that we can give a little explanation on that. Okay. All right. So when you are dealing with operations with surd, you make sure you know about these rules. Rules of surd. We have multiplication rule. That's rule 1. That states that if x, y are found in roots, okay? Remember, we call it roots. We have square roots, we have cube roots, okay? And many of them, but when you talk about this, we are considering what? This, the first one, okay? Now, if you have an expression like this, and we call it product rule because this is multiplying this, you can simply represent it like this: x times y, all in roots, okay? Now, if you talk about the second rule, that's on division rule, you may have x over y. This can be said to be x raised to power y, all in roots, okay? Now, when you look at these two, you see that you can either express it like this, and this one like the other side of it, you know. Now, but when you talk about additional rule, okay, addition rule is an exception with that of subtraction rule. Now, you cannot say that since xy root xy is this, that x plus y, this cannot give you, remember this sign, this is not equal to, that's what it means, okay? This cannot give you root x plus root y, okay? And the fourth one, that is a subtraction rule, can not also is not equal to x minus y, all in roots, okay? So when you look at these four rules, you see how they are being used. So as we go further in operations with surd, we'll be seeing some of this, okay? Or rather all of them anyway, Now, if for further illustration, let's use a number. If for instance we have 2 times 7 all in roots, okay, and since they are products, 2 times 7, okay, so this product rule and product rule obey this, and we can say that 2 root 2 times root 7, okay. So that is what we are trying to explain here, okay. And for this we can say 2 over 7, that's root 2 over 7. This can be rewritten as root 2 over root 7, okay. Now for this, okay, what we mean is that you cannot say that 2 plus 7 will give you, okay, it cannot give you root 2 plus root 7, okay. And this for division rule, for subtraction rule, sorry, we cannot say that 2 minus 7, in roots cannot give us root 2 minus root 7, okay. So note this so that you don't make mistake of using it, because this you are using this for product and division rule, okay. Now we're going to look at what we call okay, all right, basic forms of sword. All right, swords are said to be in their basic forms if they, just for instance, root x, root x, x is said to be in its basic form if this x does not have a factor that is a perfect square, okay. Now something like root 5 is in its basic form, root 6 is in its basic form, because this root 6 now has factors 3 and 2, and apart from itself and 1, and these 3 and 2, none of them are perfect square. Even root 15, for instance, okay, root 15 can produce apart from itself and 1, can have 3 and 5, but none of them have perfect square. So as they are like this, they are in their basic forms. Now you can talk about also similar sorts. Now sorts are said to be similar if they are irrational numbers or irrational number contained in that different entities are the same. For instance, if you have 5 root n plus 2 root n, okay, if you look at their sorts, they are the same. So they are said to be similar. But don't make mistake of having maybe 5 root 2 plus 2 root 5, and you say they are in their similar form. No, because the sorts contained in the expression are not the same. So for that reason, you don't consider them as similar, okay. Now we also have what we call conjugation of sorts. Conjugation of sorts or sword or swords. Excuse me. All right. When you talk about conjugation of sorts, if you have x plus y, the conjugation of this x plus y is what? Is x minus y. We can see this more on rationalization of sorts as we move further, okay. Now, and vice versa, when you have this, you can take this. Now, when you have for instance, you have root 2 plus root 3, their conjugation is simple: root 2 minus root 3. Okay, provided they have they have a sign in between. But whereby you have um, 4 roots, 3, the conjugation here is simply when you want to go for rationalization, only make use of this because there is no sign in between this. There is no positive or negative sign in between this. Rather, is a multiplication. Okay. Now, if you are given maybe minus 2 root 3 plus root root 5, okay, the sign can only affect this side. Okay, the sign can only affect this, and in a case like this, you are going to what involve this now. Okay, you are going to involve this in solving. But here, when they are alone, okay, you have to leave this aside and focus on the what, on the surd aspect of it, okay, and rationalize. So you can have this to be minus 2 root 3 minus root 5, okay. All right, I believe we understand that. Now we're going to show you more on maybe we'll simplify sorts so that we can digest more on that, okay. Let's prepare the board and give you that, okay. All right, so quickly we have this example. Simplify the following. We have root 50, we have root 72, we have root 240. Now solution. Okay, now looking at the first one, we have root 50 here. Okay, now we look at the factors of this root 50, rather 50 as an integer. For instance, we found out that when you are dealing with this, you don't just consider any factor at all. You look at a factor that among the factors or the factors of that particular number, the one that has a perfect square, that's the one that has a square factor. Okay, now if you look at all the factors you can think of from 50, 25 has what is one of the factors, and it has a square factor. Now with this we can say equal to 25 times 2 in root. Okay, now with this you can say further that this is equal to root 25 times root 2. Okay, with this now you have that root 25 is 5 root 2. So this is the answer to this. Okay, now coming to the other one, we have 72 root 72. This root 72, if you want to consider the factors of this, you also look at the one that has a perfect square, okay, in it. Now with this, if you consider this, now as someone that doesn't have, let's assume in your exam you don't have calculator, or you are not allowed to enter with calculator. Now what you do is this: you have to break this down little by little. Now let's assume that I don't know much about mathematics, and I was not allowed to enter the hall with calculator. Now instead of having rather start thinking about a bigger number that can be a divisor of this 72, I would rather say, okay, let me start with little by little of a number that I know. Now I will look at 2. 2 can go in here, but 2 is not a perfect square. Okay, I may go for the nearest perfect square. We have 4. 4 can divide this. Okay, when 4 divide this, for instance, we have 4 now. 4 into this is 1. Okay, and remainder 3. This 3 we have it here. 4 into 32 will give you 8. Okay, with this you have 18. Now for this now to come out from the bracket, remember when you like what we have here now, we have 5 root 2, and for you to return this back to to the root. Remember that the number that gave rise to this, we took the square root of that number for you to get 5. Now, for you to return it back to the root, you have to what? Raise this number to what? To power 2. Okay? And vice versa. So when you raise it to power 2, it now becomes 25. You return it back to the root. Now, for this now to come out from the root, okay, you have to take the square root of this. You now have 2. Okay? Now, you look at this again. Okay? When you look at this, you find out that the numbers that can divide this, we have 1, 2, we have 3, we have 6 and all that. But all this that doesn't have what? They are not a perfect square. Now you go further and you find out that 9 can divide this. Okay? Now you go for 9 again. Now 9 into this will give you 2. Right? Now square root of 9 is what? 3. So you also have 3 here. Now what is left is what? Only root 2 inside. Now with this, you say this times this will give you 6. So what this means now is that 6 root 2 is the answer to this. Now, since I think I know these numbers that can easily break into this, okay, quickly I will say, okay, 36 divide this can give us what? 2. Okay, now I can say, okay, 36 times 2 is equal to what? 72. Okay, and for this we now have equal to 36 root 36 times root 2. Okay, now this root 36 will give us 6 root 2. So this is for someone that maybe if you think you have already known your multiple tables, okay, you can go ahead and get the biggest number immediately that are perfect squares and forge ahead to what? To solve your maths. Okay, so whichever way you go, you are going to arrive at the answer. Now, let's take the third example. The third example is quite a big number. We have root 240. Okay, now root 240, going by what we explained earlier before, now you find out that let's assume I don't even know my multiplication table or factors much. Now, me looking at this, you know that this number is ends with 0. Now, this number alone, 24 can divide this number. Okay, when 24 divide this number, for instance, we have 1. Okay, remember 24 divide this number, we have 1. Divide this 0, we have 10. Now, what are the factors of this 24? Factors of 24, we have 4 in it. So 4 divide 24, now we have 6. So 4 square root of 4 will give you 2. So we have 6 left. Okay, now 6 times 60, 6 times 10 will give you 60 rather. Okay, now we are having 60 still remaining inside. Okay, now you also look for what? The factors of this 60. Okay, now when you look at factors of 60, you find out too that 4 can divide this as well. Now 4 divide this, now we have what? We have 15. Okay, 4 divide this, we have 15. Now when you take this square root of this 4 again, you get what? Another 2. Okay, you get another 2. Now 15 is left here. Now this times this is what? 4. Okay, 4 root 5. Sorry, 4 root 15. Okay, so this should be the answer because this is now in its basic form. Okay, root 15 is now in its basic form. So what that means is that if I want to take this 4 inside, I'll just say 4 times what? 4 times 4, which is 16. That means that 16 times 5 would have given me this what? This figure. Okay, so I can easily say, okay, 16 times 15 rather. Okay, 16 times 15. You can equally say, okay, root 16 times root 15. Okay, and this can be root root 16 is what? 4. So 4 root 15. This is the answer, okay? Now, we are going to take another example to illustrate how to get this back to what? To the original number, the original sort, okay? So stay tuned while we prepare the board, okay? Thank you. All right, this example says express in single sorts. Now, the first one says 4 root 11, second one 5 root 3, and the third one 13 root 7. Now, if you want to solution, if you want to return this to the original sort, okay, what you do is take, for instance, the first one says 4 root 11. This simply means that you are going to go back to how it was before. Now you say that 4 raised to power 2, okay? 4 raised to power 2 is what is the value of the number that gave birth to what? To this 4. So what you say? You say 4 raised to power 2 is what? 16. So we have root 16 times root 11, okay? Root 16 times root 11. So quickly we now say this will give you, if you say 16 times 11, it means 16, okay? This is 6, 7, 176, okay? We now have what? 176. So this is the expression or the sort that gave birth to this, okay? Now quickly the last one says, okay, the second one says as number 2 says 5 root 3, okay? This simply can give us that root 5 raised to power 2 is what? 25. So root 25 times root 3. So with this you can say that 25 times 3. So that will give you 75. So 75. This times this is 5. Remember 1. Remember. Then this times this is 6 plus 1, 75. Okay. So we have root 75. Okay. So this is what gave birth to this. Now the last one is 13 root 7. 13 root 7. You think about what is the square of 13. Square of 13 is 169. 169, okay? So if you say 169 times root 7, that will give you 7 times this. Let's say 169 times 7, okay? And this times this will give you 63. So you write 3 carry 6, okay? Now this times this will give you 42. 42 plus 6 will give you 48. You have 8. Remember what? Remember 4. Okay? 7 times 1 is what? 7. 7 plus 4 is what? 11. So we have root 1183. Okay? So this is the final answer. Now, with this, we can understand what we mean by simplification of sorts. Okay? Now, we are going to look at addition and subtraction in sorts. Okay? Addition and subtraction of sorts. Evaluate 3 root 48 minus root 75 plus 2 root 12. What we do is this. When you are dealing with addition and subtraction of sorts, remember they have to be in they have to be a similar sort for you to combine them when you are dealing with subtraction or addition. Now, if you look at this, you see that the sort there, they are not similar. Okay, so your mind should focus more on getting a factor that is perfect square and a common a common number in each of the words, in each of the surds, or in each of the what, the roots. Okay, so solution 3. Then for here, what are the factors of 48? Of which one of them is going to be a perfect square? Okay. Now, if you look at this, you'll find out that if you say 16 divide this, 16 divide this will give you 3, right? Yes. It's supposed to give you 3. So we have 16 times 3. Okay. Right. Now, from here we move again. We say, what are we going to have here, of which one of them will be what? The perfect square, and the other one likely will be 3. So if you say 3 divide this, quickly we are going to get 25. So we say root 25 times 3 plus. Now, for this one we have 2. Inside the root we have 4 and 3 as the factor of 12. Okay, so we have 4 times 3. Good. Now from here, now we say 3 times root 16 times root 3. Okay, minus root 25 times root 3. Okay, plus root 2. Plus 2 times root 4 times root 3. Okay. Now with this, now we have 16 inside this root, and is a perfect square. Now root 16 is what? 4. 4 times 3 will give you 12. So you have 12 root 3 minus, now root 25. 25 is a perfect square. So when you say root 25, you have 5. So we have 5 root 3 plus, now 4 is a perfect square as well. So root 4 is what? Is 2. 2 times 2 here is 4. So we have 4 root 3. Okay. Now from this, now you can now add and subtract, because looking at their sort, they are similar. Okay. So now you can add it. Whereby they are not similar, there is nothing you can do. Okay. Now from here we say 12 minus 5. Okay, 12 minus 5 will give you 7. 7 plus 4 will be 11. This is equal to 11 root 3. The final answer. So what it means is that if you have gotten the what? The sorts to be similar, you can quickly add up the what? The numbers outside the roots. So that's why we arrive at this 11 root 3. Right? Good. So there are many other things, other ones, okay, like this. Whenever you meet it, please solve it this way. All right. Now we're going to look at multiplication and division of surds. Okay. So stay tuned.